Learning target 2 is graphing simple polar equations. So we're like really simple. We're going to actually graph more complicated polar equations in learning target 4 tomorrow. Without simple equations. So this is what I mean by simple. First of all, an equation expressed in terms of polar coordinates is called a polar equation. So we don't have x and y coordinates anymore. We talked about yesterday. We have r and theta. So we don't have x equals and y equals for our equations because x and y don't exist. We have r equals and theta equals. Okay? So an example would be r equals 2 times the sine of theta. That's a polar equation. Okay? A polar graph is then the set of all points whose coordinates r theta satisfy a given polar equation. Anything you've ever done in rectangular coordinates is the same concept. If you graph a line, every single point on the line makes the equation true. If you graph a quadratic equation, every single point on the parabola makes the equation true. Right? Same thing here. Every single point on that graph has to make the equation true. Okay? Now, in rectangular coordinates, we have two very basic functions, two graphs that we should know. Okay? One is x equals a constant and y equals a constant. So here are the examples. X equals 2. If you're supposed to graph x equals 2, what does that look like? What kind of line? A vertical line at 2, right, at x equals 2. Every single point on that line has the x coordinate of 2, right? That's a very basic rectangular function, or not function, rectangular equation. So then y equals -3. What does that make? Horizontal line at y equals -3, because every single y coordinate on that line has a y value of -3. Okay? So today we're going to graph the two most basic polar equations, all right, where r equals a constant and where theta equals a constant. Okay? We're going to talk about it. So the first one is r equals 3. So remember, r is the distance from the pole. If you're going to graph any points that have an r of 3, I could start graphing any one. But no matter what the angle is, the r has to be 3. So there could be one there, and there could be one there, and there could be one there. So what shape is this going to make? A circle. With a radius of 3. Right? So if you have r equals a constant, well, that constant has to be the distance from the pole, so it has to make a circle. That's okay. That's why I used the circle tool and didn't try to draw one. I know. Questions about r equals a constant? Is it about r equals a constant? Okay. What theta equals? First of all, this is in radians. It says theta equals 3 pi over 4. And our polar plane is in degrees, so I need to change that first. So multiply by 180 over pi, and we should get 135 degrees. So we're really looking at theta equals 135 degrees. That means any point where the point will lie on 135 degrees. So we know for sure that involves the ray from the pole to 135, right? But what if r was negative? You have to go backwards. So the graph of theta equals a constant is going to be a straight line. It includes the ray and the opposite ray, because when r is negative, you go to the opposite ray. So in summary for you, if you have an equation that says r equals k, it should make a what? Circle. If you have an equation that says theta equals k, you should have a line. Questions about learning target 2? Questions about learning target 2? All right, so half your homework tonight is learning target 2. You're graphing r equals and theta equals. They're simple like that. They're just constants. Okay. Learning target 3. We're going to ignore all this so you don't get mad. All right. In this first part of this unit, we're talking about basic things about polar coordinate systems that you should be able to do. You should be able to graph a point, you should be able to graph a basic function. You should also be able to find the distance between 2 points, just like you could find the distance between 2 points in the rectangular coordinate system. So if you have 2 points, doesn't matter what their coordinates are, if you have 2 points, I know how far each of those points is from the pole. That's the r part of the coordinate. So I know how far they are from the pole. So if I'm trying to find the distance, I'm trying to find the distance between the points, and I kind of have made a triangle, right? So I have 2 known sides, and I'm missing this side right here. Does that make sense? If the angle in the middle could be guaranteed to be 90 degrees, we could use the Pythagorean theorem. But it's not going to be 90 degrees, right? We can't guarantee it's going to happen. Okay, so we can't use the Pythagorean theorem. We do know things about the angles, though. For the first point, your angle is from 0 to whatever that polar axis would be, right? That's one of the angles. The other angle is from 0 to that next ray. Does that make sense? So if I have the red angle and I subtract the blue angle, then I have the angle in the triangle. Does that make sense? Okay? So because of that, I have 2 known sides, and I have a known angle. So I have 2 known sides and a known angle, and I'm looking for the side opposite that angle. So what we can use the law of cosines. That's exactly what it does. Law of cosines, if you know 2 of the sides and the included angle, you can find the third side. Okay? So all of this stuff over here that I scratched out, that's all they were telling you. You can use the law of cosines. Now, the law of cosines normally looks like a squared equals b squared plus c squared minus 2bc times the cosine of angle A. We wouldn't want an a squared, though, if we're looking for that distance in between, so we would be looking just for a, so like for the square root. So on your note sheet, and then when I scroll down in a second, you have the formula for the distance between 2 polar coordinates. And all it is the law of cosines. Just written in r's and thetas because that's what you're given in the point. All right? So the r's are distances from the pole, so the sides of the triangle. And then you know that to find the angle in the middle of that triangle, you would have to subtract your 2 angles. It's not on the right formula sheet anywhere, even though the law of cosines is. But I'll put it on your quiz, just like it is on here. Okay, so you'll have that formula to use. Okay, questions about where that formula came from? All right, then we're going to do an example. Now I put this on your note sheet, and I'm going to put it up here. There's a cosine in the formula. Since there's a cosine in the formula, you're going to be using the cosine button in your calculator. If you're using a trig button in your calculator, it matters what mode you're in.
Radian.
It depends.
Agreed.
Depends on what your coordinates are in. So in the example right here, the polar coordinates are in radians. But in your homework, you have 2 questions for Learning Target 3. One of them is in degrees. One of them is in radians. So you have 2 choices. You can keep track. So just change the mode on your calculator to degrees when you're using degrees and radians when you're using radians. Or you can choose to keep it in one mode all the time. So if you want to keep it in degree mode all the time, that's fine. That means anytime you have coordinates with radians, you need to change those radian measures to degree measures first before you do it in the calculator. Okay? You just need to be very conscious of that happening. Okay? Everyone good with that? So all I'm saying is giving you a warning to make sure that you realize that you might need to be switching back and forth, or you might need to change some things to be in the mode your calculator's in, or whatever you want to do. Just be aware. Everyone good? All right. Then to find the distance between the 2 points, we're going to fill in the law of cosines. All I've done is fill it in. Yeah, and I wouldn't advise typing it all in anyway. You'll lose track of how many parentheses you have. I would suggest doing it in steps. Questions about where any of those numbers came from, or why I put them in the places they are? Alright, I'm going to do this very meticulously in my calculator and do a bunch of steps. You can do as many steps as you want to in your calculator. Again, I just told Gustavo I would not advise trying to type it all in at one time, because you have too many things to keep track of and things that would involve parentheses, and you'll lose track of how many you have. And then you'll get an error, and it'll say syntax, because that means you didn't close the right amount, or you closed too many or something. Okay? So I would just advise against that. Maybe do it in little chunks. Alright? Now, I am doing this in radians because I have radian measures. If you don't want to do it in radians, you could have changed these to degrees first, and the same thing. Alright, so first thing I'm going to do is I'm going to focus on this part. So, in my calculator, it takes forever for me to type things, so I'm going to go ahead and just do the difference in the two radians first. So negative pi divided by 4 minus pi divided by 6. Doesn't matter if it's in terms of pi or not, or in fraction form, because I'm going to keep going in this formula, but do not round in the middle. Use your calculator. Your calculator is able to go up and grab things from before. Do not round this. Don't write this down in steps and round every step. It's not good. Alright, I'm going to check to make sure I'm in the right mode. Should be in radian mode, and I am. I'm going to find cosine of that difference. So I know that this part is 0.2588. Then I'm going to work on all this. It's a huge product, so I'm just going to multiply it all together. So times 2 times 2.5 times negative 3, and I get negative 3.88. I'm going to go ahead and do the two squares in the front and do the sum. 2.5 squared plus negative 3 squared. Make sure you put the parentheses around the negative 3. You guys trust your calculators too much, and you think you don't need them. And then you get negative 9, and you write it down anyway, even though you know it's positive 9. So 15.25. So I have that minus the negative 3.88 I had from before. And then I gotta take the square root. So you have 4.37. Very impressive. Questions on what just happened? This is all Learn Target 3 is, using this formula.